All right, hello. This is, I guess, part 2 of me going through this textbook. And last time I was tired and I went through the beginning of the book that introduces vectors, and then it sort of quickly goes to matrices, talked about the inverse matrix. And overall, I felt like I don't really know what I was doing. I don't feel like I got to something interesting yet. And the reason is, the first reason is I don't really have a plan for this. The second is that this talks a lot about vectors, and then it goes about properties of multiple vectors, and maybe they live in the same plane, maybe they're dependent, independent, etc. Which is all very important, I guess, but definitely not the first thing that makes sense in graphical linear algebra. Vectors, and implicitly they're also talking about vector spaces. They're not supernatural. So I think what I want to do now is more like quickly skim this thing and see, aha, is there something nice? Is there something I want? Okay, that looks good. Solving linear equations. Definitely a thing I like. All right, let's go through this and see if this is what I want. My reader is a bit glitchy. All right, chapter 2, solving linear equations. Linear equations is exactly what we know how to do in graphical linear algebra. It's almost the only thing we know how to, oh god, this is very glitchy. What is happening here? Okay, good. It's almost the only thing we know how to do, right? We draw diagrams, they mean equations, and then that's it, right? The vectors and matrices and spaces are not basic notions in our world. I haven't even explained them much. They're evolved, they're derived objects. So what am I doing? So it's good that we start with equations. Let's start with equations. The central problem of linear algebra is to solve a system of equations. Yes, and indeed, what we do in graphical linear algebra is not just equations, it's systems. Indeed, we have many of them at the same time. All right, two equations, two known. Let's write this one. That's x minus 2, that's 2, that's minus, that's plus, right, x minus 2y equals 1. And let's see how I want to represent this. And then 3x plus 2y equals 11. One way of writing this thing is like this. So this is like the number 1. Another way would be to go a bit beyond graphical linear algebra and use affine algebra, because we do have this thing where x is here and there's a sort of vertical bar here. That means x equals 1. So this would be 1, and this would be, if I multiply by 11, this is another way of writing it. I don't know which is the most relevant right now. Let's see. Let's see how far it leads. Two equations, two unknown. We begin a row at a time. Okay, they're talking about straight lines, points. Okay, so they're giving us a geometric intuition of what's happening. Fair enough. The row picture shows two lines. Okay. This is not super usable for me. column picture, glitchy. Okay, that's the coefficient matrix. This is written as a matrix thing. Right. Still kind of using, holy shit, this is weird. Okay. Wait, what are they doing? Elimination goes from A to triangular U by a sequence of steps. That could be interesting as in it could be nice to see the graphical steps that correspond to that. All right. Okay, but they're not doing that right now. 3 equations, 3 unknown. Still like very going through one example. And part of what I want to get from this textbook is also what they, like, I want to know what the textbook aims to teach. Because that's sort of an open question for me. I mean, like, what kind of things do people need knowledge about for concretely? And obviously, the main thing is solving a linear equation, but matrix form of the equations. It's just doing more matrix form. I feel like a very useful thing for me, and that I will keep in mind, is to actually go through the process of elimination graphically. That would be really cool. That would be really cool. But if I think I read it correctly, looking ahead. Okay, yeah. All right. So this is sort of looking ahead. They haven't yet. Oh my god. They haven't yet explained those 4 steps. Sort of methodically. Okay, so one thing I will do is show some examples of sort of manual matrix inversion. Actually, I don't even want to talk about matrices at this point, just manual solving of a system. That would be really cool. So that's the thing you can do. The matrix as an entity need not be very like I might not need that to explain how to solve the thing at the beginning. Matrix notation, multiplication in MATLAB. That's nice. We definitely want to use MATLAB. It's definitely harder to give. I don't know how hard it is, but I don't know how I will give geometric intuition in GLA yet. All right, problem set. Oh, I mean, I could do some of the problem sets. That could be some very interesting videos. Except they draw planes and vectors. I don't want that. Challenge problems. Hell yeah. That's boring. It's fun. Sudoku matrix. The idea of elimination. Now this is tasty. Okay. Let's write this again, I guess, because we had it. And then they form, actually this is really neat. So they have 2 systems of equations that are equivalent, I believe. So they reduce this one, make it sort of simpler by doing the operations. And what are the operations? Let's see. Okay, so that's 1. Then I've got -2 for y, 3 2. Holy shit. It's not very legible, but okay. So this is this one, right? Not quite this one yet. Let's do it like this. That's 11, and then okay. This one is pretty similar, except try again, duplicate. Now the top one, this one is the same. The bottom one has no x, which is neat. And instead it's 8. Y equals 8, which is obviously y equals 1. That's easy to simplify. We'll just simplify like this. But let's not get ahead of ourselves. So the claim is that these two describe the same x and y. And then how do they do that? And then y equals 1. That's very convenient indeed. Okay, I need to figure out what upper triangular looks like in GLA. Shouldn't be too hard. And then back substitution. How did he, that's my question. How did you get from the first pair of lines to the second pair? We subtracted 3 times the first equation from the second equation. Okay, how does that, let's try to do that. Let's copy this and add a new page. And then, I don't like this background, but whatever. Try to figure out what they're doing. You take this one and you, so first, actually, let me, and then what was it? 3x plus 2y, wait, no. Oh, that is the case. Well, it's a lot easier to eliminate the other thing, but let's not bother with that. So they times 3 this one and then remove it. What does that mean graphically? I guess I should have figured this out before making the video. I don't know. This is super rambly. This is what you signed up for. I'm live doing this. Alright, so here's one way of doing this normally, and then we'll try to replicate this. One way is is first do the multiplication. So 3x minus 6y equals 3. And then do the subtraction. Because one way of doing this, right? The first step is I want the x here to match the x here. I think the way I would do it and graphically is by sliding the 3 over there. So this 3 slides over there and then gets duplicated like that. Right? I'm essentially using the fact that 3 is the same as 3. Right? So this is x equals y, and z is 3 times those two, and then this is the same thing. So the first step might be there. I don't exactly know if this is going to work. And then what am I doing? And I want to subtract the x and the y. So one way of reading this is that I get, this is sort of what I'm getting. 3x equals this, and then I'm sort of putting it in, right? And then I've got 3 plus 6y plus 2y equals 11. And that's what I want to get. So 3x is this node here, for sure. And 3x equals 3 plus 6y. So I keep sliding. I'll see. I think I'll figure out some general rule after I'm doing that. I'm done doing that. So I keep sliding the 3. So the 3 can also slide across this dot. So it goes like this. Right? The fact that it slides is distributivity of addition over multiplication, or whichever way around. Now I've got 3x here. This is 3x. Definitely equals, yeah, that's 3 minus 6y minus 6y, which is plus 6y. And now I want to substitute this thing. What's funny is that I'm kind of losing, maybe not. I don't want to lose this one too much. Just, what I'm doing so far is more like this. So I'll have to recover this one afterwards, maybe by dividing, who knows. And then, so I've got this, and then I guess I can just copy this whole thing through this node. Why is this allowed? Also this is, this is a bit more mind-bending than I expected. Can I make this better? Because like this shape is not nice. I kind of like to have shapes like this, which is almost, just easier to track. You don't make sign errors so much. So let's do that. So first is 3, and then it's copied into here, and then it's this one. Then actually I'm going to move these to the other side. So I'm going to have on one side 3, and on the other side this one. And because I'm moving the lecture to the other side of a white dot, the minus sign pops here, which this cancels with this, so I can just remove those two. What am I noticing? The first thing I'm noticing is that this requires a pretty comfortable knowledge of manipulating things in graphical linear algebra. You need to be used to sliding things around, simplifying things, seeing where you want to go. It's not clear. This is what I want to be doing. Also, this is clearly a lot more complicated than whatever is happening here. At least, even for me, being used to all that madness. Okay, so now I'm swapping those two. And I guess maybe the reason is that I can go a lot faster than this. Maybe I can teach people faster things. It will be easier. Okay, so there's 2 white nodes. 2 black nodes. 1, 1, 1, 1. Okay. And I may as well just duplicate this one as well. So there's going to be 3, 3. This one goes here, this one goes here. All right. Next. It's definitely not more convenient. No one will be fooled. But let's see if I can eliminate the variable anyway. What is supposed to happen here? Well, so first thing I notice is that I'm going to slide all of that a bit out of the way. This is a bit messy. 3. Don't want to make a sign error. Sign errors happen when you're not clear if something is a plus like this or a plus like this. So if I do a sort of ambiguous thing, it might be this one, it might be this one. If I'm not careful, I'm going to make a sign error because one is plus, one is minus. Okay, now I can slide the 3's here. So 3 goes here, and then I've got this. Now I've got, this is x, this is x minus 1. And then there's the 3 here, slides here, and also this one slides. So I can remove those 2 and get a 3. Okay, good. It's all cancelling out. And then this 3 and this 3 go through. And then this one just goes here, and then this one just goes here. Why is this so messed up? Oh, I think I'm literally just cancelling this slide that I did here. All right. Unfortunate, but anyway. So I feel like what should be happening now in this thing is something like 3x 3 plus 6y, or maybe the factor 3 is not really there. Oh yeah, actually, yeah, that's x equals 1 plus 2y. That's a lot easier. And then I substitute x. So I've got 3, 1 plus 2y plus 2y equals 11. Actually, this step is stupid. Yeah, I don't know why I bothered with all the 3's. Well, it's there now. Alright, so 1 plus 2y. X is... Oh, indeed. That's x. That's 1. And that's 2y, right? Because it comes from here and then it's copied here. So we do have x is 1 plus 2y. And also here, we also have the same here in this node. It's the same as this node. This x is 1 plus 2y. And so if multiplied by 3, so if I slide, if I sort of entangle this whole bit, I should get something I need. I won't. And then all those 3 sliding was pointless. Good to know. Right, so that's how we went. Some pointless steps. This is the new thing. So first things first. Let's give me some space. And then the 3 is here now. 3. So let's slide it. I feel like I messed up the direction of the 3 because I'm not supposed to. Am I supposed to divide by 3? Who knows? Let's trust me for now. 3. Okay, so now I've got this whole mess with the white circles, which I'm going to fix somewhat by flipping this leg to the other side. So now I get this one is still on this side, and this one now has a minus and links to here. And now I can move all of this. Okay. I'm going to forget something if I do it too quickly. I feel this is a very nice demonstration of why graphical algebra is not actually practical for solving small equations, which is unfortunate. Okay, so this one goes here. This one goes here. Here we go. Nice. So now I've got what? What do I have? What do I want to have? Let me slide the minus everywhere. I don't have a minus here. And now I have, you know, 1 plus whatever's here plus this thing. So, you know, it's just 3 things added together. And actually I can push the 2's together and pull the 2's. I was not intending to do a very extended calculation, but here I am. Then let's, this one goes, I want to go the other way, I think. So let's move this. Okay, so now there's a minus sign and still the plus, and it goes here. But this is connected to this, so it's just, you know, all of them are equal. So this is equal to this. Ah, nice, look at this. Now this is x. This is 2y, so I've got x minus 2y equals 1. Nice. And then this mad loop is happening. What is happening? I'm going to slide the 3's. So I don't get to do 9th grade divisions. So I've got 3 here, and then 3 here, instead of wherever they were before, right? So this 3 goes here, over here, and now, okay, this. Okay, now what do I have? Look at this. Here I have, in the most simple way possible, a node that is, you know, move it out. This is 3 minus 11, which I can easily calculate. 3 minus 11 is minus 8. So that's minus 8. There we go. And then this one, I bend the other way. So it goes like this, and then like this, and there's a minus. And all 3 minuses just cancel out in here. And finally, this works sometimes. Okay, we're almost there. This is, you know, if this is z, this is like 3z coming from the top plus z from the bottom. So this is 4z. So we've got 4 and then 8, which is multiply by 4, divide by 8 if you go this way, or 8 and then divide by 4. So this is simply 2. And then finally we can super simplify by sliding both 2's up to there, so we get 2 minus 0 here and then here. What does this say? That's y equals 1 here, and then minus 2y plus x equals 1. Right, that's minus 2y plus x equals 1. And the obvious thing we can do here is, in fact, this 1 copied. There's a clear thing I can do if I copy a 1. That is very simply a 1 here and 1 here, right? This says y equals 1, and then I've substituted the y up there, so this is like x minus 2 equals 1. So then I move this leg to the other side, so I get this one, then a minus 1, and that leg, the minuses cancel. So I have 1 plus 2, which is 3. I have now simplified. Wait, this is what we want. Okay, and here we go. We have found a solution, which is x equals 3, y equals 1. Oh god, that was so long. It took me half an hour to get there. I have now fully convinced you, I hope, that this is not practical at all. Right, we wanted to know how to go from there to there, and I definitely got confused along the way, but overall, this is not practical. I mean, it's sort of okay. You kind of get the hang of it pretty quickly, but I wouldn't do it for anything big. Oops. It's kind of more systematic. No, it's not more systematic. It can be made systematic, right? It can be some kind of rule about, there's a copy here, so like you sort of want to substitute whatever's here into here, so which involves like taking this whole thing and copying it through the dot and then simplifying. There is a systematic way of doing it, and it would be very similar to that thing. I don't know how interesting that is though. I should probably stop here because I've got another long time. But breakdown of elimination. No solution is really interesting. Equation, 3 unknowns. Well, I can't imagine doing this in GLA. Madness. Madness is afoot. Equation. Overall, this going through a textbook is not working really well. Unless it gives me a lot of examples. I could go through a lot of examples. Don't really know what I want to. I don't really know what I want to get to by doing this. Well, this is enough for one video. So thank you for watching, if anyone actually does.